So we continue solving linear systems in three variables, and here we have this word problem, and it states, for performances during the weekday, a local symphony group sells adult tickets for $4, children tickets sell for $2, and senior tickets sell for $3. For weekend performances, adult tickets sell for $6, children tickets sell for $3, and senior tickets sell for $4. For one particular season, the theater group had a total of 1,000 tickets sold. The weekday performances had total ticket sales of $2,800, and weekend performances had total ticket sales of $4,100. Determine how many tickets of each age group were sold during the season. So as we come across these word problems, every word problem contains two things, rows and columns. And the best way to represent rows and columns is through a table. So to construct a linear system that models this word problem, we'll first construct a table that itemizes the values and their relationships. So it reads right here how many tickets of each age group were sold. Those are the values that are going to fluctuate. Those are the variables. And there are three of them. There's the adult tickets right here, the children tickets, and the senior tickets. The tickets are going to be listed across the top of our table, and anything listed across the top of a table creates columns. Now for the rows tell us the instances in which or how the variables occur. And we can see that we have a weekday occurrence here, and we have this weekend occurrence here. Also, the rows will always contain the overriding totals. And we have a total here of 1,000 tickets that are sold. We have weekday performances at $2,800 and weekend performances at $4,100. So the table would look something like this. You can see here we have our adults, our children, our seniors. Those are the values that are the variables. Across the top, they create these columns here. And of course, you could see across here we have our rows. And for the rows, we have our instances of how they occur. You can see right here, for the weekday, $4 for adult tickets, $2 for children tickets, seniors for $3, and for a total of $2,800. And of course, you can notice at the bottom here, we have the total number of tickets sold. So we just go ahead and add up the adult, the children, and the senior tickets, and that comes out to be 1,000 tickets sold. So now that we have a table that represents this scenario, we could turn it into our system of linear equations. So we will have 4x plus 2y plus 3z, and that's going to equal 2,800. Then we have 6x plus 3y plus 4z. That's going to equal to 4,100. And then finally x, that's the adult tickets sold, plus y, the children tickets sold, plus z for the senior tickets sold, and there were 1,000. We enclose it in this curly brace here, and this is the system of linear equations that models this scenario. So now that we have this, now we can build our matrix that represents this system here. So we'll start with our bracket. We'll have 4, 2, 3. Put in our vertical line, 2,800. 6, 3, and 4. Put in our 4,100. And then 1, 1, and 1. And put in our 1,000 and close off our bracket. So obviously these are our variables, our coefficients of our variables, and these are our constants. So then of course we'll use row operations to solve for this matrix. And of course the goal is to create unit columns so that we have ones that go across the diagonal here. So we'll do that. We'll use our row operations. So what we can do is, if we start with a 1 up here, here we have 1s right down here. So I'm going to swap out these two rows right here. So we'll take row 1 and we'll swap it with row 3. And that's what's going to transpire. So then we'll have 1, 1, 1. Put in our vertical line. 1,000. Then 6, 3, 4, 4,100. And we swap that with 4, 2, and 3. And our 2,800. And then we can close off our bracket. So now, since we're going to start with a 1 up here, we want to change this into a unit column. So the other values have got to be 0. So we could start either with this row here, or we could start with the other one. It doesn't really matter. Let's start with the second row here. So we'll take row 2 and we'll subtract 6 times row 1. One times 6 is 6. 6 minus 6, 0. That's the whole idea, right? 1 times 6 is 6. 3 minus 6, negative 3. And 1 times 6 is 6. 4 minus 6, negative 2. Put in our vertical line. 1,000 times 6 is 6,000. 4,100 minus 6,000 is negative 1,900. Put in our bracket and fill in the rest. And then we do the next for row 3. So we'll take row 3 and we'll subtract out 4 times row 1. 1 times 4 is 4, and 4 minus 4 is 0. So we'll start it down over here. One times 4 is 4, and 2 minus 4, it's negative 2. And of course, 1 times 4 is 4, and 3 minus 4, it's negative 1. Put in our vertical line. 1,000 times 4 is 4,000. 2,800 minus 4,000 is negative 1,200. Close off the bracket, and we'll fill in the rest. And then 0, negative 3, negative 2, and negative 1,900. So we've now created a unit column here. So this column is done. And here we have a negative 1 right down here in the Z column. So maybe we'll go down here. Everything is negative. So we'll change this all positive. So we'll take negative 1 times row 3. And that'll give us 0, 2, 1, put in our vertical line, and 1,200. Close off our bracket and fill in the rest. 1, 1, 1, and 1,000. 0, negative 3, and negative 2, and negative 1,900. We can then change the rest of these into zeros. Again, it doesn't matter which row we start with. You could start with the first row or the second row. We'll start with the first row. So we'll take row 1 and we'll simply subtract row 3. One minus 0 is 1. 1 minus 2, that's negative 1. 1 minus 1 is 0. That's the whole idea. put in our vertical line. 1,000 minus 1,200, that's negative 200. And we can close off our bracket. Then fill in the rest. 0, negative 3, negative 2, negative 1,900. 0, 2, 1, and 1,200. We'll now do the same for this row right here. So we'll take row 2 and we'll add 2 times row 3. So we'll continue it over here. 0 plus 0, obviously that's 0. 2 times 2 is 4. Negative 3 plus 4 is 1. 1 times 2 is 2. And negative 2 plus 2 is 0. Again, that's the whole idea. 1,200 times 2 is 2,400. Negative 1,900 plus 2,400 is 500. Close off our bracket and fill in the rest. 1, negative 1, 0, negative 200, 0, 2, 1, and 1,200. So again, we've now made this into a unit column. So now we can switch over here. This is where we want our diagonal to occur. So now we're going to change this into a 0. So we'll take row 1 and we'll add row 2. One plus 0, that's 1. Negative 1 plus 1, that's 0. 0 and 0, 0. Put in our vertical line. Negative 200 plus 500, that's 300. Close off our bracket and fill in the rest. 0, 1, 0, 500, 0, 2, 1, and 1,200. So the last value to change into a 0 is this one right here. So we will take row 3 and we'll subtract 2 of row 2. Zero and 0, so we have 0. 1 times 2 is 2. 2 minus 2 is 0. And 0 and 1, so we're going to have 1. Bring down our vertical line. 500 times 2 is 1,000. 1,200 minus 1,000 is 200. Close off our bracket and fill in the rest. 1, 0, 0, 300. And 0, 1, 0, 500. So now we have our diagonal here. Every column is a unit column. It creates this diagonal here. So for this linear equation right here, this is x. So then x is equal to 300. And of course, x represents our adult tickets. But we'll put down here x is equal to 300. So that's 300 adult tickets sold. For our linear equation here, this would be y. That means y is equal to 500. And of course, y represents the children tickets. So y is equal to 500 children tickets sold. And finally, z, which is this one down here, z is equal to 200, and z equals our senior tickets sold. So z is equal to 200 senior tickets sold. So now we're going to check this. We're going to slug these values back into the original linear system to see if it satisfies all the equations. So here is our original linear system that models this scenario. So we'll go 4 times x, and x is 300. plus 2y 500 plus 3z, and 3 is 200. And altogether, that should equal 2,800. 4 times 300, that's 1,200. 2 times 500, that's 1,000. And 3 times 200, that's 600. Add it all together, and it does equal to 2,800. So we'll try it for the next equation. 6x, and again, x is 300, plus 3y, and of course y is 500, plus 4z, and of course z is 200. And does that equal to 4,100? 6 times 300, that's 1,800. 3 times 500, that's 1,500. And 4 times 200 is 800. Add them all up, and it does equal to 4,100. So for our last equation here, we have x plus y plus z, so we're going to have 300 plus 500 plus 200. And that should come out to be 1,000. So each equation is satisfied. So the solution is there were 300 adult tickets sold. That's x is equal to 300. That represents the adult tickets. 500 children tickets were sold. Y equals the children tickets. And 200 senior tickets were sold. That equals z equals to the seniors. And there we go.